Okay, this is Student Notes 11.5, Inscribed Angles. The first thing we're going to talk about is the Inscribed Angles theorem, which just states that the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so if you take a look at these, a couple of these pictures here to the side, the measure of the inscribed angle, so this would be the angle right here, angle ABC, is half of whatever the arc is. Well, the arc, the intercepted arc, is A to C. So if I told you that the intercepted arc was 50 degrees, then now this time, since it's an intercepted arc, not a, I'm sorry, now that it's an inscribed angle, not a central angle, it is half of whatever the arc is. So let's say that the angle here were 40 degrees. Well, the angle's half the arc, so that would make the arc 80 degrees. And if I said here that this arc was 20 degrees, that would make the angle half of the arc, which would be 10 degrees. Okay, so let's go ahead and apply this to example number 1. We're looking for the measure of angle PRU. PRU. Okay, so this is the angle that we're looking for. It is inscribed, not a central angle, it is inscribed by this arc, PU, which is 118 degrees. So the angle would be half of 118. Half of 118 is 59 degrees. Okay? And vice versa, if we know the arc, SPU, okay, well, we need this whole thing. So right now we're looking for what is this arc? Well, the arc is double whatever the inscribed angle is. So if this is the inscribed angle is 27. So double that, that would make this 54 degrees. So to find whatever S to P to U is, we would actually need to add 118 together with the 54. And we would get 172 degrees. And the last thing we're looking for is arc, SRU. SRU. I guess this is asking about the arc going this way, even though this looks kind of like it's a minor arc. It might not be, though. Let's subtract and see. So if we know this arc is 172, the other direction all the way around would have to be 360 minus 172. Oops, gotta borrow. So 10 minus 2 is 8. And 15 minus 7 is 8. And 2 minus 1 is 1. So this is a major arc because it is a little bit bigger than 180 degrees. It's 188 degrees. Okay, let's go ahead and look at, this is called a corollary. It's kind of similar to a theorem or just a rule. If inscribed angles of a circle intercept the same arc or are intercepted by the same quarter arc, then the angles are congruent. Okay, all that means is you have an intercepted arc here of 3 different angles. You have this one right here, which is the red angle, angle ACB. Then you have the blue angle, angle ADB. And you have the green angle, angle AEB. And all 3 of those angles have the same intercepted arc. It's this yellow arc right here, arc AB. All their endpoints are from A to B. So because all their endpoints are A to B, and the intercepted arc is arc AB, then all 3 of these angles are congruent. This angle is congruent to this angle is congruent to this angle. So what we can conclude is that the measure of angle ACB is congruent to the measure of angle ADB is congruent to the measure of angle AEB. So all three of these angles would have to be the same. So if I told you that this arc was 60 degrees, then that would make each one of these angles half of the arc, which would be 30. Okay, so let's go ahead and look at example number 2. We have to find the measure of angle EDF. Well, if you notice, angle EDF and angle EGF, those two angles have the same intercepted arc, and that arc is EF. Notice that the two first and last letters of their angle name are E and F, so that's the intercepted arc. Okay, if they both have the same intercepted arc, that means that the two angles are congruent to each other. So in order to solve this problem, we're going to have to set these two angles equal to each other. 2x plus 3 is equal to 75 minus 2x. Okay, so we're going to bring the baby to the mama. In this case, we have a negative 2x. We want to bring it to the positive 2x by adding it to both sides. Because it is already negative, we have to add it. So 2x plus 2x is 4x plus 3 equals 75. Subtract the 3 from both sides. So 4x is equal to 75 minus 3, which is 72. And then divide both sides by 4. So 72 divided by 4 is 18. Okay, but we're not done yet because the question asks us to find the measure of angle EDF. EDF is the purple angle right here, which is 2x plus 3. So 2 times 18 plus 3. 2 times 18 is 36, plus 3 would be 39 degrees. So the measure of angle EDF is 39 degrees. Okay, we're going to save example 3, 4, and 5 for class. So go ahead and turn your paper onto the back side. Let's go ahead and look at this guy up here. What it says, an inscribed angle intercepts a semicircle if and only if the angle is a right angle. Okay, so if you think about it, this angle right here is 90 degrees. It's marked with a 90-degree angle. And here are the endpoints on the edge of the circle. So this right here is the intercepted arc of our inscribed angle, which happens to be 90 degrees. Well, we know that if we have an inscribed angle, its intercepted arc is double what the inscribed angle is, or the angle is half of what the intercepted arc is. And notice that this intercepted arc is a half circle because of the diameter that cuts right here. So this half circle has to be 180 degrees, and the inscribed angle is half of that, which is 90 degrees. Example number 6, find the value of A. Well, here's A, and it's pointing to this angle right here. Well, what can we tell about this angle? Well, it's an inscribed angle with its endpoints at W and Y. Notice that W and Y also connect to make a diameter, which means that this arc right here has to be 180 degrees. Since this arc is 180 degrees, this angle, the inscribed angle, has to be half of that, which is 90 degrees. So what we can do is take 5A plus 20 and make it equal to 90 degrees. And solve for A. Subtract 20 from both sides. So 5A is equal to 70. And then divide 5 by both sides. So 70 divided by 5 is 14. Okay. Our last theorem we're going to talk about today is if a quadrilateral is inscribed in a circle, that means within the inside of the circle and all the vertices are on the edge of the circle, then its opposite angles are supplementary. In other words, they add up to 180 degrees. So what are the opposite angles here in this? Well, the blue angles, D and B, are opposite, and the red angles, A and C, are opposite. So what this is saying is since these are opposite of each other, and they're also inscribed inside of a circle, then they have to add to 180 degrees. So the measure of angle A plus its opposite angle, the measure of angle C, have to add together to equal 180 degrees. And then vice versa, the measure of angle B added to its opposite, the measure of angle D, has to equal 180 degrees. Okay? Well, we're going to use that concept on example 7, but we're going to save that one for class. So let's go ahead and look at example 8 and 9. Decide whether these quadrilaterals could be inscribed in a circle. Show work to prove your answer. Well, we know that quadrilaterals can only be inscribed in a circle if their opposite angles are supplementary. So let's look at these opposite angles. Well, the opposite angles here are 120 and 60. Well, we added 120 and 60 together, and that does equal 180 degrees. So that does tell us that opposite angles add together to be supplementary. And if this is 100 degrees, this one would have to be 80 degrees because there has to be a total of 360 degrees in our quadrilateral. And 100 plus 80 obviously equals 180 degrees. So yes, this can be inscribed in a circle, and here's our work to prove that it can be because opposite angles add together to equal 180. Okay, example number 9. The only angle we have here is that this one is 60, but we see here that these lines are parallel. So if this is 60, this angle down here would have to also be 60 because they would be alternate interior angles from each other. And vice versa, if these are 60 and 60, these would have to be 120 and 120. Well, if you're going to add the opposite angles together, 60 is opposite of 60, and does 60 plus 60 equal 180 degrees? No, it does not. It equals 122 degrees. So this cannot be inscribed inside of a circle because opposite angles do not equal 180. Same thing with the 120. 120 plus 120 is 240, so that would not work either. So this could not work out for us inside of a circle. We're going to do the rest of these questions tomorrow in class, so I will see you then.